All right, video 2 for solving trig equations using identities. So starting with example 5, we have 2 cosine squared of x plus 3 sine of x minus 3. I would love to be able to factor this, and the reason I say that is because I have 3 terms. I have a squared term, I have just a regular term that would be replaced with represented with a variable, and then a constant term. Okay, however, I have a cosine squared and then I just have sine. So we can't just jump straight to being able to factor in terms of a quadratic. We need to, that's right, replace it using an identity. So our identity, Pythagorean identity, sine squared plus cosine squared equals 1, can be rewritten to isolate cosine squared equal to 1 minus sine squared. So our first term, 2 cosine squared of x, is now 2 multiplied by the quantity of 1 minus sine squared of x. Okay, we've done that in other ones, so just the only difference is now we have a 2 in the front, and you better distribute that 2 through to both of those terms. That is the biggest common goofy mistake that we tend to make, so don't do that one. Okay, so 2 cosine squared of x turns into 2 minus 2 sine squared of x after we've replaced and multiplied through by 2, plus 3 sine of x minus 3 equals 0. That's the rest of the equation. Okay, now I've got everything in terms of sine. Awesome. We want it to be in terms of one trig function if we can, for sure. We're just going to combine some like terms. So negative 2 sine squared of x plus 3 sine of x, 2 minus 3, and then minus 1 is now equal to 0. When I factor, I prefer not to have my first term being negative. You can, it doesn't matter. So I'm either multiplying or dividing through by negative 1. In essence, I'm changing the signs of every single term in the equation, except for the 0 because it's always 0. Now we can factor. All right, so what multiplies to 2 and adds to negative 3? Okay, the only things multiplied to 2 are 2 and 1. They both have to be negative. But in this case, I have that coefficient in front of the sine squared term, so I need to put that over top so that I can reduce and get my factors correct. I'll have a 2x minus 1 and an x minus 1, or a 2 sine of x minus 1 multiplied by a sine of x minus 1. And then we are going to set those two factors equal to 0 as we've done with everything else up to this point. So I have 2 sine of x minus 1 equal to 0. To isolate sine of x, we have to add 1 and divide by 2. So we're trying to solve where is sine equal to positive 1/2. It's positive in quadrants 1 and 2 at pi over 6 and 5 pi over 6. All right, and then our other factor is sine of x minus 1 equal to 0. So when we isolate, we determine where does sine equal positive 1. That only happens at pi over 2. Okay, great job. We are plugging and chugging along. Here we go. Number 6. Cosine of 2x equals sine of x plus 1. That's right. That first term, cosine of 2x, is a double angle. Okay, we are going to replace cosine of 2x with cosine squared of x minus sine squared of x. And then I'm going to go ahead and set everything equal to 0. So I'm going to subtract sine of x and subtract 1. I'm probably going to have to do that anyways. Okay, we're almost there. We have most of the terms in terms of sine, but that first term, cosine squared, we're going to have to change that one again. Yep, another Pythagorean. Cosine squared is 1 minus sine squared of x. Okay, so that's a straight replacement for the first term, and then the rest of the problem stays the same. Minus sine squared of x minus sine of x minus 1 all equals 0. Now we can start combining like terms and getting things together. So I have a positive 1 and a negative 1. Okay, well that's 0. Awesome. Negative sine squared minus sine squared. That's negative 2 sine squared of x. Then I'm left with minus sine of x, all equal to 0. Okay? And what are we going to do here? Are we factoring? GCF? Big factors? Or are we taking a square root? That's right. We have a GCF. You got it. The GCF, it could either be positive or negative sign. Whatever floats your boat. Doesn't matter. I'm going to factor out a positive sign, leaving me with negative 2 sine of x minus 1 equal to 0. Take those factors, sine of x, set it equal to 0, and solve. And the other factor, negative 2 sine of x minus 1 equal to 0, and solve. So sine of x equals 0, that's already isolated. Sine is 0 at 0, pi, and 2 pi, because we're including 2 pi in our solutions. The second factor, negative 2 sine of x minus 1. To isolate sine of x, I have to add 1 and then divide through by the negative 2. So we're looking to see where is sine negative 1/2. That's in quadrants 3 and 4, and that will occur at 7 pi over 6 and 11 pi over 6. Great work. All right, we got a couple more. We're almost done, gang. Here we go. Number 7, secant squared of x minus 2 tangent of x equals 4. Okay, we did one kind of similar to this already, and we tried to go a little bit different route, but then we found that replacing secant squared with tangent squared of x plus 1 was that Pythagorean identity. That tended to be the better route. So let's try that again for this example and see where it gets us. So secant squared is replaced with tangent squared of x plus 1. Continue the rest of the problem, minus 2 tangent of x, and then I'm going to go ahead and subtract 4 to set the entire equation equal to 0. If you don't do it in the first step, do it in a step later on. That's totally fine. It looks like I've got a couple of terms to combine. So tangent squared of x minus 2 tangent of x minus 3 equals 0. 1 minus 4 is negative 3. Okay, and yep, we're back to factoring. What multiplies to negative 3 adds to negative 2. That's got to be a negative 3 and a positive 1. So those factors, x minus 3 and x plus 1, would become tangent of x minus 3 and tangent of x plus 1, all equal to 0. And yes, we are going to set those factors individually equal to 0 and solve. Okay, so when we isolate tangent in the first factor, we add 3 to both sides. Tangent of x equals 3. Okay, right now, we haven't gone through on how to determine these values if they're not on the unit circle. So we're just going to put that the solution is not on the unit circle, and we'll get to that in the next lesson. So we can come back and revisit these and actually determine those values. Okay, so that one, not a solution on unit circle. The next factor, tangent of x plus 1 equals 0. When I isolate tangent, I want to know where does it equal negative 1. Tangent is negative in quadrants 2 and 4 at the pi over 4 radians, so that'll be 3 pi over 4 and 7 pi over 4. All right. Last example. Okay. We haven't seen anything like this before. No, you are not going to distribute. That's right. Look back at some of the other identities that we've done. We have a sum of 2 angles, and we have a difference of 2 angles. So in order to solve this example, we are going to have to fully expand both of those so that we can get the correct values. Now, could you shortcut it? You could. Would you get the right answer? You possibly may. But y'all, you need to make sure that you're using the formulas as they're given. So a sum of sines is sine of the first angle multiplied by cosine of the second plus cosine of the first angle multiplied by sine of the second. Okay, sine of x cosine of pi over 4 plus cosine of x sine of pi over 4. That's the first one. Okay, got that one. Let's do the next one. Expand the difference. Sine of x cosine of pi over 4 minus cosine of x sine of pi over 4. All of that equals -1. So that was sine of the first, cosine of the second, minus cosine of the first, sine of the second. Okay, now, yes, again, like we've been doing, we keep making a big mess, but we're going to combine like terms and simplify. Positive cosine of x sine of pi over 4, negative cosine of x sine of pi over 4. Those terms eliminate themselves. When I add one sine of x cosine of pi over 4 to another sine of x cosine of pi over 4, I get 2 of those terms. 2 sine of x cosine of pi over 4 equals -1. Okay, yes, you can go ahead and divide through by 2. You sure can. You also, and we haven't done this for a little while, actually evaluate what's cosine of pi over 4. Okay, so that's another step that we need to take. 2 sine of x, cosine at pi over 4 is the square root of 2 over 2. All of that equals -1. So really, 2 sine of x and square root 2 over 2 were all multiplied together. 2 square root 2 over 2 and sine of x are all multiplied together. One big giant fraction. That means that the 2 leading coefficient and the 2 in the denominator reduce, leaving me with the square root of 2 multiplied by sine of x equal to -1. Okay, keep plugging and chugging along. If we divide through to isolate sine, I get sine is -1 divided by the square root of 2. Now we've done this several times. If you still need to rationalize and show the work, do so. But 1 over square root 2 always rationalizes to be the square root of 2 over 2. So in our case, because it's a negative, we're going to have a negative square root of 2 over 2 equal to sine of x. And now we just need to say, hey, y'all, where does the y value equal negative? That's quadrants 3 and 4, square root 2 over 2. And that's at the pi over 4s. So that will be 5 pi over 4 in quadrant 3 and 7 pi over 4 in quadrant 4. Great job with all that work. I know it was a lot. We got 2 videos for it. Let me know if you guys have any questions, and I'll see you later.